What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to have a look at this concept called skewness. And this is really just a tool for you to use in order to communicate effectively based on the patterns or the trends within a data set. So skew is really identifying any sort of pattern, but what we're really going to focus on in maths in year 9 and 10 is talking about the frequency of something occurring. So that means we're going to see data sets like this. We might have a line graph or a polygon which has frequency on the side. Or we might have a box and whisker plot. The important thing about these box and whisker plots is that where I've got that red mark, that small bit in the middle, that means there are more scores in that 25% than there are in the large one. Sometimes my students do get a little bit confused here because they think, oh, a larger box means more people. That's not what we're saying at all. In fact, it's actually the opposite. A larger box means that the 25% of scores are more spread out. So the closer they are together, the more frequency there are of those numbers that are really packed in. In this lesson, we're only looking at unimodal data, meaning that there's only one high point in the frequency. And because of that, we're looking at three distinct types of data. The first one is a normal distribution. That's what we would expect would happen in an average experiment. We could also have a positively skewed data or negatively skewed data, and we're going to have a look at what these mean in a second. Spoiler alert, it might not be what you think. So normal distribution is really easy to see. It's where we look at something that is symmetrical, and that's actually another word for it. This could be a symmetrical data set. Another word for this is sometimes called the bell curve because it looks like a bell, and it's really easy to identify straight away. It kind of just looks right. A really big key of these normal distributions is that the mean, the median, and the mode are all exactly the same. They all happen within the middle. We know that these three measures of center don't always line up, but when they do, we call it a normal distribution, and it will look something like this. Our positive skew and negative skew will look something like this. And just take a second to guess which one's which. I know when I learnt this, I got this absolutely wrong. I got it mixed up every time. It's really important to know that the one on the left is the positive distribution or the positive skewed data set, and the one on the right is the negative skewed data set. And you might be thinking that is super dumb. The frequency for the positive one is down the negative side. And we're just going to have a look at how we can remember that moving forward. The way that I think about it is that the tail of the curve tells the story, not the high point. So we thought, having a guess at that one, that it would be the most frequent number. If that's positive or negative, that would tell us what it is. But we've got to look at the tail of the data set in order to get this right. I remember it that tail is kind of like a story, like a fairy tale, and that's how I remember it. The tail is what's important. So for this one, the highest number is down the negative side and the tail is going towards the positive side. So that means that this is a positive skewed data set. Even though there are more negative numbers, the frequency's down that side, this is still a positive skew. So if we just have a look at a box and whisker plot, this one does look confusing because students do think that because the top half in this one is bigger, the positive side looks like it's bigger, that it must be more numbers. But remember, the smaller means there's more jammed in there, so the frequency there is higher. Again, you have to look for the tail here, okay? Because that top 25% has a really long tail up the positive side, we know that this is a positive data set. And then, wouldn't you guess it, it's the exact opposite for the negative skew. We've got the highest frequency happening up the positive side, and the tail is pointing towards the lower numbers or the negative side, so this has a negative skew. And again, just on that box and whisker plot, look for the tail. The long tail will tell you the information that you need, and the tail for this one is down the lower side. So because this isn't intuitive, there are ways for you to kind of remember this. One of the ways that I was taught was imagine that there's like a skier on top of a mountain, and if you're at the top, which side would you rather go down? The really steep drop or the nice cruisy run that would take a little bit longer and you would have a bit more fun? Because we want to go to the higher numbers in this one, to the positive side, that means that this is a positive skewed data set. And the reason that it was explained like this to us is that skew kind of sounds like ski, so you could remember that. That never really worked for me, but it is one way that I've seen explained. The way that I always remember this is I kind of wiggle my toes in an exam. So we're going to look at the right foot first. So right kind of means positive, right? It's got a positive connotation. And if you think about your right foot, if you looked at your toes as data points, the big toe would be the highest frequency. So if we drew a curve over our toes, we would have the long tail towards the positive side on our right foot, and this looks like a positive distribution. So right foot is positive, and then on your left-hand foot, the exact opposite. We're saying left here is negative. The big toe in the middle has the highest frequency towards the positive side of that foot, and the bell curve has the tail going towards the left again. So as you probably realized, skew in statistics will be used differently, the exact opposite to what you might hear in real life. So if we have a look at this graph, we'll see what we mean. So this is a temperature graph that is telling us whether or not a year was above or below an expected temperature for the whole year. And you'll probably see this in science when we're talking about climate change and global warming. So a headline for this graph would be pretty easy to write. Oh, the world or the climate is skewing hotter. The world is getting warmer. But if we draw a polygon on top of this, we've got a data distribution that has most of the numbers up on that positive side and the tail going down towards the negative. So if we looked at this data, we would say statistically, this has a negative skew. So this is just something you have to keep in mind when we are doing this topic. If you get a question like this, just double check. Make sure we're not focusing on the high points, but we're focusing on the tail. That's where the important marks are, and that's how you can get through this incredibly easily. Thanks so much for watching this one, guys, and I'll see you later.